Hi, today we'll be starting chapter 3. So far we've learned how to write code that goes sequential. So I might start by asking the user, for example, grade, input, enter your grade. And then maybe create a variable extra credit equal to 5, and then print a message. Your grade was grade, print after extra credit, your grade is, and then print them the new grade. So we can calculate the new grade plus equal to extra credit. We've learned how to do that. So, you know, if someone enters their grade as 56, we'll say now it's 61. Now, what we want to learn in this chapter is how to do conditional execution. Conditional execution means there is code that I wrote and I want to choose whether to run this code or not. So, for example, let's look at this code here. And we're going to look at the code and then we're going to look at the flow chart. So here we have a program that says x is 5, x equals 5. And then it's checking, it's saying if x is less than 10, so it's checking if this variable 5 is less than 10, x is less than 10, it's going to print smaller. So you see print smaller is kind of indented, and we're going to go over the syntax in a minute. So here, if I look at it, x is 5, and then it's going to ask, is 5 less than 10? The answer is yes. So it's going to print smaller. And then there's another check if x is greater than 20. And now the question is 5. Is 5 greater than 20? And the answer is no. So whatever is under the if statement here is not going to get executed. So here I have a conditional execution. This print line that's under the if statement might get run or might not get run. So now you're writing code that you know might not get run depending on some circumstance. If you look at the flow chart, here we have a variable x set to 5, and then when you see a diamond, the diamond just indicates it's a question. So the question is x less than 10? If the answer is yes, it's going to print smaller, and it's going to come back to do the next check. If the answer is no, it's not going to do the print smaller. It's going to skip over it and immediately go to the check if x is greater than 20. And so the syntax that we want to use for doing the if statement is if, and then what comes after is something called a Boolean expression. And Boolean means true or false, yes or no. So we want to have an expression there that's a test that will give us back basically a yes or no answer. And yes or no in programming is called true or false. True means yes, and false means no. And then we put a colon at the end, those two dots, and then underneath we put the statements that we want to execute. So here, for example, I might add a check, for example, if grade is over 90, I put a colon, and when I press enter, you will find that Python, the IDE automatically does an indentation for me. So it's helping me, it's telling me that your code needs to come here. So I'm going to say print, great job. So let's run this code and test it again. So if they enter 56, their grade is 61. I see that great job did not get printed because the grade was not over 90. But if I run it again, and this one time I give them a 90, now the grade is 95, so it says great job. So here, this is the conditional statement. So what I want to show you now is how can we build those Boolean expressions so that we can do a lot of checking. So we can use some comparison operators that you've probably seen before. Some of them you've seen before probably. So we can use less than or equal. We write it with a less than and an equal sign. We have greater than and equal, greater than. And then if I want to check if something is equal to something else, instead of using one equal, I have to use two equals. And the reason being is that one equal means I'm assigning. So if I say grade equal to 10 or equal to 100, I'm changing grade. But if I want to check if it's equal to something, I'll use the double equal. So for example, here, I want to check if the grade is equal to 100, I'll say perfect. If I run this code and I give them, they had 95, now it's going to print perfect. So the way we check if something is equal to something else, I will use a double equal sign. Here we could do some extra checking. For example, when they enter the grade, I can say if grade is less than 0, you know, print invalid grade. Okay. And so if they enter like -8 for their grade by mistake, it'll say invalid grade. Now it's going on and doing the extra credit still. We'll try to fix that later. But you can do checks like greater than, less than, greater than, equal, equal. And then there's also the not equal. So if you want to say it's not equal to this, you can do that too. So here, for example, if I ask if 10 is greater than 5, the answer is yes, 10 is greater than 5. So I'm going to get 10 is larger than 5 getting printed. If I have here a equal 9 and I check is a equal to 10, well, 9 does not equal 10. So I'm not going to get anything printed. Okay, and just notice, like we mentioned before, the statements that come under the if statements must be indented. In addition to those comparison operators, there are things called the logical operators that allow us to do a little bit more. And so we can use an and, an or, and a not. Those are the three. And what I want to do is kind of give you an example. Let's say I tell you that in order to pass my class, you need to do the classwork and you need to do the project. Okay. So we'll call that A and we'll call that B. Okay, and here we're doing an and. So if someone comes and they do the classwork, so classwork, they do the classwork, they do the project, they did both, they will pass the class. So passing is true. If they come and they do the classwork, but they don't do the project, will they pass the class? No, because my condition is that they have to do both the classwork and the project. If they don't do the classwork, but they do a perfect job on the project, again, they will not pass the class. And definitely if they don't do the classwork, they don't do the project, they will not pass the class. So with an and condition, you see that the only way for an and expression to be true is if both parts are true. And so this is what this truth table is showing. If I have some condition A, some condition B, the only way for an and condition to be true is if both A and B are true. So for example, when we're doing the check here, I can say if I want to do these, I want to run this code only if it's a valid grade. I can say, for example, if grade is greater than 0 and grade, for example, is less than 100, do all that's under here. So I'm going to highlight all this and press the tab key, which is above your caps lock. And so now I'm saying if the grade is greater than 0 and the grade is less than 100, I'm going to do that. So if they enter like a 0, it's not going to do anything because I didn't put an equal sign here. Maybe I should put an equal sign. Let's put an equal sign. So if they say -7, it's not going to do anything. If they already have a grade that's greater than 100, it's not going to do anything. But if I enter any other grade, it's going to execute this code. So I can use an and to build complicated expression, and it can be more than one thing. So I can say if grade is greater than 10 and I don't know, extra something else. I don't have anything else to write, but we can build more complicated expression. So this is how the and is used. There's also an or. So the or behaves a little differently. So if I tell you that, you know, at the end of the class, you have a choice between the final exam and the project. Okay, so you can do either or. And I just want to tell you from now, this is not true. Okay, this is just an example. This does not apply to our class. So someone comes along, they do an excellent job on the project, and they don't show up for the final. Will they pass the class? Yes, because I said you can do either one. It's an or expression. They don't do the project, so they decide to take the final and they do good, they will still pass the class. Someone says, I'm going to do the project and I'm going to do the final just to make sure I know everything. Definitely, they will pass the class. But if someone decides not to do the project and they decide not to do the final, well, they will not pass the class. So we see that with an or condition, it's always going to give us true, except in the case where both parts are false. So in an or condition, if you just satisfy one, of them at least, you will get a true back. But if you don't satisfy any of the parts, you get a false. So here with the or condition, you see that it's always true. If B is true, yes. If A is true, yes. If A and B are both true, yes. The only way you can get a false is if both of them are false. And so here I can say, for example, another check that says if the grade is less than 0 or the grade is greater than 100, print grade. Okay, so here I want to check for invalid grades. So the invalid grades are kind of disjoint sections. So if it's less than 0, that's a bad grade. If it's greater than 100, that's a bad grade. Oops. Well, let's just move this up to the top so we can see it happening first. Okay, so here I enter -9, it says invalid grade. If I say 107, it says invalid grade. But if I put another good grade between 0 and 100, I don't get that invalid grade printed. I get this code executing. And the last logical operator that we can use is called the not operator, which is just the exclamation, which is similar to the exclamation mark that we saw when we were doing the comparison. But here we can just say not something. So I can say, for example, if not grade equal to 0. So if the grade is not 0, I'm going to print exam, for example. So here, if they enter any grade, I will say student attended exam, but if they got a 0, it's probably because they didn't attend. So here didn't print the student attended exam. So you can use the not also. Instead of doing it this way, you could have also said if grade does not equal 0. So these both are the same. Will give you the same results. So let's just test it out. So here, if I get a 0, I put a 0. If I put a non-zero number, then I get student attended exam printed twice because this was true and this Boolean expression was also true. So you see that these two expressions are equivalent. Not something equal and then not equal. You can just kind of like do the distributive property where you distributed the negative sign. Here you're distributing the not. So these are the different logical expressions that we can use. And so let's look at an example on the next slide to practice. So here, if I have -6 is less than 0 and 12 is greater than or equal to 10. Well, -6 less than 0, that's true. 12 greater than or equal to 10, that's true. So true and true gives you true. And you might want to pause this video and do them yourselves and then check your answer. Here, 3 greater than or equal to 2, true. 3 greater than or equal to 4, false, but we have an or. So we get a true because as long as one of the results one of the parts of the expression are true, and an or, we get a true. Now here, is 3 greater than or equal to 2? Yes. Is 3 greater than or equal to 4? No, but we have an and. And for an and to be true, all the parts have to be true. So this one gives us a false. So like we saw in the example that I gave you, one of the use cases we can use the if check for is checking numeric ranges. So if I ask the user to enter a number between 0 and 100 inclusive, and when we use the word inclusive, it means including 0 and including 100. We can do checking in this way. So here I'm saying if x is greater than or equal to 0 and it's less than or equal to 100. So here I'm checking the valid range. And if I wanted to check the invalid range, like to issue an error, for example, I could say if x is less than 0 or x is greater than 100. And sometimes when you're building those expressions, it might be a little confusing. Should I use an and or an or? And the way to help you is just pick a number. So pick a good number, 22, and ask yourself, does 22 make this true? And if it does, you got it right. And then pick an invalid number, like -10, and see, does -10 make this true? And if it does, then you probably got it right. So I know it's sometimes confusing whether I should have greater than, less than, and, or. So do your best to build it and then test it with a few numbers. Now there's something called short circuiting. And what short circuiting means is that we're going to try to, the Python interpreter is going to try to save time during the processing. So if I come here and I have an expression and it's an expression. Oops, let's try it again. So let's have an expression that's an or and another expression that's an and. So with an or, if I have a true here, do I really need to go and check what this is? I don't, because with a true, with an or, as long as you have one true part, the whole thing will evaluate to true. So this, we don't really need to check this. And so what short circuiting means is that if you have an or expression and you immediately find a true, the computer, the interpreter will not go and evaluate this. It will not even look at it. It's not going to check if it's true or false. So it's trying to save some time. With an and, on the other hand, if I find the first expression is a false, I know that this will immediately give me a false, because there is no way that I can get a true out of this. So I really don't care what the second part is. So this is called short circuiting. It's when the Python interpreter decides that it knows the answer immediately and it doesn't need to go and check the second part. So that's what short circuiting means. Let's just try practicing these. Is 3 greater than 4? Is that true or false? Okay, that's false. And notice that false is with an uppercase F. And if you try printing that, you will get an uppercase F. We'll also be using the true and false later to do other comparisons, but for now, just know that true and false start with uppercase letters. Is 4 greater than 3.99? True. 4 greater than 4? False, because I don't have an equal sign here. Is 2 plus 2 equal to 4? True. True or false? So here I have an or, and I have one true, so the whole thing gives me true. Not false, the opposite of false is true. Now here I have an or and an and so I have 4 is greater than 5, false. 3 less than 4, true. So now I've got a true, and then I have 9 greater than 8, that's true. And if you have a not, whatever the answer in the middle is, you negate it. Okay. So now we saw how to do an if statement. Sometimes it's not just if this is true, do something. I want to say if something is true, do something, otherwise do something else. So for example, here I have code that says x is 4, and then I'm going to check is x greater than 2. And I want to do something different depending on the answer. So if x is greater than 2, I'm going to print bigger. Otherwise, I'm going to print smaller. And when I'm all done, I want to print all done. So here I have a question. If the answer is yes, it's going to print something. If the answer is no, it's going to do something else. And at the end, it'll do the print all done. So if I go to my code and try to fix that. So for example, if the grade, let's just use this one. Here, if the grade is not 0, I'm going to say student attended exam. Otherwise, I'm going to say print student has 0, probably was absent. Okay. So now, regardless of what I enter, like if I say 100, it'll say student attended exam. And if I say 0, it'll say student has a 0. So I am basically saying I want to do something in every situation. When this test is true, I want to do something. And when the test is false, I want to do something. So this is the when the test is true. And this is what's going to happen when the test is false. You could also have more than one statement under the if or the else. So here I could say student has a 0, probably was absent, maybe go check attendance. So I can do more than one thing. So I can, if they have a 0, I'll say student has a 0, go check attendance. So you can have more than one statement. As long as they're indented, they will all happen underneath the if or underneath the else. So here's another example. I ask the user to enter their grade. I read it in, I convert it to an int, and then I do the check. If the number is greater than 6, I will say passed, otherwise failed. So when they enter 8, 8 is greater than 6, it'll print passed. When I run it again and say enter 4, 4 is not greater than 6, so it's not going to go to the if, it'll go to the else and print failed. So for the classwork for this part of the chapter, what I want you to do is ask the user for the length and width of 2 rectangles. So you're going to ask them, what's the length of rectangle A? What's the width of rectangle A? What's the length of rectangle B? What's the width of rectangle B? So let's say they enter 10 and 20 for the first rectangle and 40 and 5 for the second rectangle. What you're going to do is calculate the area, and just recall that area of a rectangle is length times width. So here the area of the first rectangle is 10 times 20, which is 200, and 40 times 5, which is 200. Now notice here that the answer is a float. And I just want you to think, what does that mean about the length and width that I entered? Are they ints? Did I convert them to ints or floats as I was reading them in? So you're going to print the area of both rectangles, okay? And then you're going to use an if statement, an if-else statement to print me a message that says whether the areas are equal or not. So here, 200 area of A and area of B are equal, so it says areas are equal. Here, if I check if area A and area B are equal, they're not, so you're going to print areas are not equal. So do it in Mu and then test it on HackerRank and let me know if you have any questions.